Welcome to the PoDIUM project, an EU-funded initiative dedicated to advancing cooperative, connected, and automated mobility. PoDIUM operates 3 living labs across Europe, in Germany, Italy, and Spain, to test these innovations directly on public roads. In the Spanish Living Lab, Use Case 2 demonstrates how connected infrastructure and vehicles can improve traffic safety and efficiency in urban corridors, especially when high-priority vehicles and vulnerable road users are involved. The Spanish Living Lab in Barcelona is centered on the Gran Via corridor, a complex urban area at the heart of the city where we use dynamic traffic signal control, cooperative maneuvers, and artificial intelligence-based video processing to enhance urban mobility. Ahead of the trials, the project partners prepared the test site in Barcelona to ensure realistic conditions. This included deploying physical and digital infrastructure components and setting up the emergency and connected vehicles. Behind the scenes, advanced systems like the traffic management system, the digital twin and edge cloud infrastructure ensure seamless communication. Our network relies on 5G standalone and C-V2X technologies to provide reliable, low-latency communication. The research and demonstration in Use Case 2 focuses on 3 critical scenarios. The first is providing priority to emergency vehicles. The second is optimizing traffic flow across the urban corridor. The third is ensuring the protection of vulnerable road users at complex intersections. In Scenario 1, when an emergency occurs, the firefighter's truck starts the corridor and shares its planned route with the traffic management system via GNSS-based positioning. The system clears the truck's path by coordinating traffic signals along the corridor. At the same time, the system receives cooperative awareness messages from connected and automated vehicles and enables cooperative maneuvers by sending them decentralized environmental notification messages that alert them to the approach of the emergency vehicle, so that connected and automated vehicles move out of the way to clear the lane for the emergency vehicle. These maneuvers reduce response times to emergencies by improving traffic flow along the corridor and at intersections. In Scenario 2, connected and automated vehicles continuously share their position, origin, and destination data with the infrastructure. This real-time information feeds the urban digital twin, enabling the traffic management system to implement dynamic control strategies, optimize routes, and reduce congestion. The system is designed to alert connected automated vehicles to incidents along their routes by sending them DNM messages, enabling them to change their itineraries. In Scenario 3, AI cameras installed on the infrastructure detect vulnerable road users, such as pedestrians and cyclists, and estimate their trajectories. The system then identifies any potential collisions between vehicles and VRUs. If so, warnings are sent to vehicles via DNM messages, enabling them to adjust their time and distance and reduce hard braking to perform smoother maneuvers. At the same time, warnings are sent to the VRUs via a dedicated app to prevent collisions with vehicles. In this scenario, communication is established through C-V2X technologies, which reduce critical latencies. The trials also featured the Miller automated shuttle, showcasing how connected and automated vehicles can interact directly with infrastructure. These demonstrations took place at the UTAC circuit in France, where the shuttle successfully showcased the core cooperative aspects of all 3 Use Case 2 scenarios. While operating in automated mode, the shuttle responded directly to DNM messages and maneuver recommendations received from the infrastructure, executing each maneuver successfully and safely in real time. Remote operators supervised the shuttle's activity via live dashboards to ensure it operated safely and reliably in all circumstances. The successful tests in Barcelona and the closed-circuit validation confirm the effectiveness of the system by integrating connected and automated vehicles, traffic and emergency services, and vulnerable road users.